All right, this video is to help us understand how to graph a polynomial and do it fairly smoothly. The first thing you understand about polynomials is their end behavior. It's going to help you identify really what the vast majority of your graph is doing, what it's going to do out to the right side and out to the left. The notation for end behavior often can be kind of confusing, so I'm going to try to explain that for you as well. The big idea is we're going to be talking about infinity, because rather than traveling to a number, we're traveling to sort of an idea. We're moving infinitely to the right, or essentially x is approaching infinity. So just realize that when you talk about x approaches infinity, that's saying we're moving to the right side of our graph. As x goes to negative infinity then, well, x travels again left and right. Negative infinity would essentially be saying let's travel to the left side of our graph. Our question is, as we go right or left, what is your actual function doing? What is the line you're drawing on the graph doing? Is it going up or is it going down? And the nice part about all polynomials is they only go up and down. When we start to talk about rational functions or talking about exponentials or logarithms, they may start to approach a certain line, such as a number, and flatten out. However, polynomials, again, the nice part is they just go up and down. So if we said something like f of x goes up, essentially f of x approaches a positive infinity. Again, we're going infinitely upwards. So think of f of x goes to infinity as, again, going up, and f of x going to negative infinity as going down. Okay? So when we go to fill in our chart, that's what we're going to look at. So the next thing we need to do is basically graph our functions over here. So if I was graphing f of x equals x plus 3, I'm just going to hop onto my calculator, and I'm going to type in f of x equals x plus 3. Or you'll notice that I've got that in here as f1 of x. Well, when you take a look at that, as we go to the right, your line just appears to be rising upwards. As with the slope of 1, it should rise upwards. And as we go to the left side of our graph, if we kept going left, 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 farther and farther into the negatives, we're just going down. Again, just like a positive slope should do. So we come back here and realize that our graph, again, a quick sketch of it, looks something like this. And we're going up to the right, so f of x goes upwards on the right side, and we're going down to the left, so negative infinity as we go to the left. Go ahead and graph these other four functions, and I will fill in the chart for you, and we'll see if we find any sort of a pattern. Pause the video now. All right, as far as x squared is concerned, again, if we hop onto our graph here, we can quickly check mark that x squared, and we know that x squared makes a parabola, and notice that negative x squared is going to make a downward facing parabola. And when we talk about negative x squareds, we are opening downwards. So when we go back to our graph here, we can say that on the graph, we got a parabola kind of facing this direction, or essentially both ends of our graph are going downwards. So to the right, we're going down, to the left, we're going down, or basically negative infinity both times. Again, we can hop back to our calculator again, down here, and we can switch to our next function and take a look at what it looks like. Remember that a cubic function is going to be sort of this S-shaped curve. It's going up on the right and down on the left, but crossing right through the origin, as it was just a simple x cubed. So if we tried to sketch that real quick, again, we're going to curve almost like half a parabola this way, but then the other half is curving back up that direction. And again, it's cubic. It's a little faster than a parabola, a little quicker than a quadratic, because its third power kind of is stronger than x squared. But the big idea is to the right, it appears that we're going upwards, and to the left, we're going downwards. Let's continue on with our next function. So we're taking a look at f4 here. We're doing x to the fourth power, so realize a fourth degree polynomial. And you might notice this one has something in common with x squared. Oops, sorry, wrong button there. This one has something in common with x squared. You'll notice that, again, it's doing a little W shape there, which we'll study more of that later in the chapter. But the big idea is to the left we're going up and to the right we're going up. Both ends are going the same direction. And if we think about it, why would x to the fourth and x squared both have ends that travel the same general way? Well, they're both even exponents. And that's really the rule that we're trying to get at. You'll notice that if your degree is even, and you've got a positive number in front, both ends are going the same direction because we're even, and because we're a positive x to the fourth, both ends are traveling upwards. Whereas, again, x squared was even, but notice we had a negative x squared, so that negative leading coefficient ended up sending us downwards. Now, if that's the case, then odd exponents should also have a general rule. And x to the first, notice, went up to the right, down to the left. X to the third went up to the right, down to the left. Or basically, if you put both of those on the same screen, the end behavior would look fairly similar. They're both just traveling sort of like with a positive slope. Both ends are going opposite directions, up right and down left. X to the fifth should follow that same pattern, but notice again, now we've got negative x to the fifth. So when we think about it, well, up to the right, down to the left seem to be the pattern for odds. But if we flip that over, that negative leading coefficient, my guess is we're going to end up going up to the left and down to the right. So we can fill in that we're going negative infinity to the right and positive infinity to the left. Let's double check our graph and make sure that's really the case. So we'll highlight F5 here, and you'll notice that that does seem to be the case. You might have to zoom in or zoom out a little bit. And if you just grab your axis and kind of do that, you'll notice that to the right we're going downwards and to the left we're going upwards, and we're looking pretty good. So I think we've got our general rule there. The leading coefficient test is just the test to say when you look at the degree and the leading exponent, or sorry, the leading coefficient, can you determine the end behavior? Again, odd exponents, the two ends will go opposite directions. If it's a positive leading coefficient, you're going right and up, down and left. If it's a negative, you're going right and down, right? Negative infinity down here, x to the fifth, and up to the left because of that negative leading coefficient. Even exponents, your end behavior should travel the same direction. So squareds and fourth powers, both ends go the same way. Then again, negatives, they're both going downwards. Positive, they're both traveling upwards. Now, how can we use that? We can really take advantage of that when we're thinking about actually making a graph. It's the first thing you want to really determine when we think about graphing. So here we've got an x to the fourth, but a positive leading coefficient. Remember, x to the fourth tells us they're going to travel the same direction, but a positive leading coefficient tells us they both should be traveling upwards. That really gives us a great idea where to put our points. Now we need to know where all the fun stuff happens, where the action happens, and all those swerves like we were talking about with that W shape before. And what you can really do there is take advantage of your calculator for now and go ahead and type in that function. And you'll notice again we get that nice W shape going on because of that x to the fourth power. A great way to find a bunch of points there is to use your table. So you can press Control T, or you can go to Menu and turn on the table, and you can get a whole lot of points directly from there. So let's go ahead and scroll back. At -3, we're way up at 21, and you'll notice again we already knew that if we moved farther and farther left, our graph was going to travel up, 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 up. So it's well beyond what we really want to graph. But knowing that, it means that that first point we want is going to be at -2, 0. So let's go back to our graph, and we can go to -2, 0, and know that from then on, we're just really traveling upwards in this direction. That's where that end behavior really helps out. Then let's use some more points from our table here. Let's go ahead and scroll down a little bit. At -1, we're at 1, and at 0, 0. So we're going to plot 0, 0, -1, 1. So again, that's where you get that W shape going on, right? That first part of our W. And actually, it looks like we crossed through the axis as well. Make sure you use the picture to your advantage. So I better go back here and fix that real quick. I got to drop down a little bit before I come upwards here. There we go. Looks a little bit better. Then you'll notice we get another 0 just past 1. We get another x-intercept, but we're also going to drop way down here. So it looks like in between there, or down at, or up at 1, we're at -3. So 1, -3. And we're just going to let that sort of happen. As I saw, we had a 0 kind of right there. So for now, again, just have enough accuracy to see that stuff. And let's see if we can't get one more point possibly Nope, looks like up at 2, we're already up at 16. Remember, our end behavior said we're going infinitely upwards. So we're just going to let this thing go almost straight up. And there is a general shape there. Again, if we spread out our graph a little bit or we found more points, we could be even more accurate. But just try to plot as smooth a curve as you can. And don't forget to label your axis. Right now we were counting by ones, so this would have been 3 here and 2 up here, or we could label out 10 out here. Something to tell us that we counted by ones. I hope that helps you with graphing polynomials and describing the end behavior. Good luck and have fun.